Good afternoon. This is episode 2 of the Meridian recording for the EDMS platform. In episode 1, we talked about how to leverage our data management platform to manage the configuration associated with a code delivery. Again, what is a code delivery? A code delivery consists of a package of information that is used to or is intended to be migrated into a target environment in order to affect the behavior of the target environment's runtime. The target environment may be your QA environment, and you need to deploy a program, a Java program, if you will, to that environment so that that could be compiled and assembled and incorporated into the runtime of the target environment. So what we're going to do today, again, what we've done on yesterday is that we've shown how we capture data related to a particular feature set. Now we're going to show you how we capture source code related to a feature set. At the end of this demonstration, we're also going to show how the Meridian API is exposed so that all of the calls that are being triggered from our graphical user interface, which is shown here on this screen, can also be triggered from any other third-party platform such as Jenkins, Puppet, or a curl script. Whatever the case may be, EDMS exposes all of its functionality via a collection of REST-based services that could easily be integrated into other processes like Jenkins and Confluence and so forth. In this particular example, we'll start with our code example. In the case of code, we mentioned with configuration, the configuration comes from various data sources. We could pull data from any source using an environment definition. There's another component separate from environment definitions, which are called our source code repository. Very much like an environment definition, it defines a source. However, a source code repository will define a source for a repo, such as get, SVN, or TFS, or anything like that. In this particular case, the source code repository refers to a specific branch within the repo, and it is configured to monitor that repo every minute looking for commits. In reality, you may have this set up to poll every hour, but for the purpose and sake of this demonstration, we will show how we can automatically poll this repo looking for commits. In this case here, I will then show you how to trigger such a commit. In this case, I have this Java file. With this Java file, I will make a change to this Java file and say DevOps with OUC. And now that I have this Java file, I could use any IDE. It could be Eclipse, whatever the case may be, to integrated development environment. It could be any tool of your choice. The end result is that a change that you've made is then detected. That change can then be committed and pushed to that branch. And in doing so, that will trigger the DevOps feature set. So in this case right here, if I did EDMS DevOps, just an arbitrary tag name, this could be your Jira ticket number, it could be some identifying item here. But at the end of the day, we commit those changes to the remote branch, and as we commit those changes will be automatically picked up by EDMS, and it will extract that code. So in the case of the continuous integration process, the continuous integration process will then result in a CI package being automatically created. So as such, the continuous integration package is created, and the continuous integration package will contain the code associated with that particular feature. Let's see if we could wait for that process to run, and then we would just take it from there. Let's look at our continuous integration stream here. And you can see where CI packages are automatically created in some of our historical ones. And if I go into that particular package or release, I can see that that release contains this continuous integration package, and this package contains the source code. This is where it automatically extracts the source code from the source code repo. And then once it's extracted the source code from the source code repo, the continuous integration process will create a release, and then that release will communicate with the build server in order to generate the code build. So what exists inside of this release here that you see on this screen is an actual compiled image that's been received from the build server. So again, the release will share the source code with the build server, and then the build server will in return send us back a compiled release. And that compiled release is then used to be deployed into a target environment where that code is to be installed. So that is how the code integration process works in terms of integrating with a source code repository such as Git or SVN. Is that the code is automatically identified based on a commit into a given commit or merge into your master branch, and our continuous integration process will automatically poll and push those changes. So that is how we do the DevOps portion of that. And again, like always, you can always combine your source with your source code with your configuration, and together it allows you to couple the process of keeping your code and configuration in sync to represent the feature that you're driving towards. The other thing that we wanted to talk about here is how does our integration API works. So EDMS has this capability for you to put it in debug mode. When you're in debug mode, any activity that you perform within EDMS, such as creating a migration request for a given package, if I went to a test package here and I created a migration request and I chose the target for which this migration is intended to go, please approve my package. My features are now ready for QA. And when I save this migration request, it saves it as normal, and I can also come over here and I can approve it, auto approved. All of that activity generates the templates for integration. So essentially it gives you the endpoint, and it also gives you the JSON structure for triggering activity in EDMS. The point that I'm emphasizing here is that EDMS, this web-based client, is just a GUI. It is a client, a graphical user interface for interacting with our backend services. These same backend services can be triggered from Jenkins, Puppet, Jira, Confluence, whatever third-party integration system you have. You can orchestrate and use EDMS to manage all of that activity. For example, if I'm going to take a snapshot of all of my configuration from a given environment, if I were to take a snapshot into a new package, and I created that package and I saved that package, and I want to automate the activity associated with pulling all of the configuration from a given environment, and then I can do that here. I submit the batch process, I tell it 8 threads, and if I want this process to be automated, I could take this batch job submission for creating the snapshots of the MMM all config, and I can take that, copy and paste, and put it in some integration engine or service bus that could trigger EDMS to do the work that I've done here from the graphical user interface. And that concludes the presentation of how the code integration works with a source code repository such as Git. It also includes the process of showing how the EDMS API can be exposed and consumed by third-party orchestrator. So that will conclude that presentation. The third presentation and final presentation would be about how to identify test data and subset that test data from a production environment in order to support automated data testing and selection based on a Jira ticket and the business test cases requiring such data. Thank you. Enjoy your day.